Every observer experiences the celestial sphere from their own position. The sun, the moon, the stars, the planets, the Milky Way, they all appear to move across a dome of perception centered on the observer. That's not flat earth theory. That's how astronomy has worked for centuries. The celestial sphere model places the observer at the center and maps all celestial objects onto a dome of vision. Navigators and astronomers have used this framework for centuries because it accurately describes what is being observed. When you observe the sun from your position and I observe the sun from my position, we're both observing a celestial light moving across our individual dome of vision. The angles, the elevation, the direction, these are measurements relative to each other's position. Now, take every observer from every position on Earth simultaneously. Compile all their angular measurements. Sum up all those individual observer-centered celestial sphere measurements together into one collective framework, and what do you get? A model that matches the globe. The globe model is the mathematical summary of individual observer-centered experiences compiled into a collective framework. It's internally consistent because it's built on observations. It's built on real observations. Of course the math works. It's describing what people actually see from their actual positions. That mathematical summary doesn't describe the physical shape of the ground beneath our feet. What it describes is the collective output of an electromagnetic field that curves light and frequency back to each observer. That's why when you think about the sun, when it walks on the water, that sun angles right back to the observer. You're going to see the reflection of the sun on the water going back to you. Somebody else down on the other side of the beach is going to see the reflection of the sun going back to them. That reflection is not in some universal physical space that we can measure. That's angled back to the observer. And that's how all celestial objects work. In plasma physics and electromagnetic field theory, the behavior of light through a medium is governed by the properties of that medium. A toroidal electromagnetic field would curve the propagation path back toward the observer. Each observer would experience a dome of perception. The collective measurement of those domes would produce a spherical mathematical framework. The globe model is internally consistent because it accurately describes those observations, but internal consistency doesn't establish physical geometry. It establishes that the model fits the observations. Both a physical globe and an electromagnetic field system curving light back toward the observers would produce the same observations. That's the kinematic equivalence that I've been talking about, and the observer-centered nature of the celestial measurement.